Let me get a thumbs up with somebody if you can hear me. Hello, hello, hello.
Yeah, I can hear you.
Awesome. Good afternoon, guys. Thank you guys for being here. Uh, quick disclaimer before I do start today's video. In today's class, my wife went to a leadership course. She left this morning. And there's no daycare for the evening. So I do have my son today and tomorrow. So I sincerely apologize. Um, if you hear him or if he's, pulling me to the side, whatever. At the end of the day, I'm still a father first, instructor second. So please bear with me. If if for whatever reason, it takes too much of my time, I will stay back here later and provide any kind of help I can to anybody, uh, past our timeline, um, to make up for any kind of disruption. But without further ado, let's go ahead and jump straight into today's lesson. Yesterday I believe we finished the day talking about bubble sort, right? Um, and today there's not much to talk about before jumping to the next assignment. I'm gonna go ahead and share my screen. Uh, we were doing bubble sort dot py. Somebody has a hot mic. If you could please mute it, I would greatly appreciate it. Thank you guys. We did bubble sort dot py, right? And then we saw an example here, right? The next slide is bubble sort count dot py. It's gonna be about 95% the same as bubble sorts, but there's gonna be like one thing added in there. All right, so we're gonna take 10 minutes today, in the beginning of class, to kind of get you guys, warmed up, kind of recapping yesterday's material, uh, by letting you guys do bubble sort count.py before we continue with the next part of today. All right, so we'll take 10. You guys can go over it, and because it's so similar to yesterday's, I spent like 30 minutes talking about bubble sort yesterday, and how it works. So today I would like a volunteer to kind of talk through their code and talk to us, the class, as like what your code is doing. Uh, that way I can ensure that one of you guys at least knows what you're talking about. And at the same time, the rest of the class hears it in a different manner. Sometimes it's better if someone else says it in a different way. Uh, it might fit better for other people. So we'll take a volunteer after count, and then you guys will talk through it. Time is 5:33. Let's go ahead and take 10 minutes to do this. And like I mentioned, 95% of the code is going to be very similar to bubble sort. You're probably just going to have to add one or two lines of code. So don't copy paste it. Kind of try to do it from scratch. Time is 5:34 now. Let's come back at 5:44, and then we will take a volunteer. Someone that was able to complete the assignment, which everyone should have. I'm hoping for. Owen,
I'll do it.
get it.
Can you see my screen?
Yeah, let's move that readme a little bit to the right though. Shift that readme a little bit to the right.
Okay. There we go. So essentially the same thing. I just added two variables. Comp, short for or what was it? Comparisons, and then X, which is short for exchanges. So for every comparison, that would be in your nested for loop. So every time that nested for loop does an iteration, it's going to plus equals 1 for my comp variable. And then if there's an exchange, which I put it in the if statement in this nested for loop for the actual exchange, then my X variable is plus equals 1. And then once it's done with everything, with both of these for loops, then I just return both of those variables. So I'll give an example. I'll just go in terminal. Or I'll just do it through up here. So I ran the program. It returns 21 and 1. So for that first one, this first list, it had 21 comparisons and then just one exchange. For the second one, it was 45 and 45, and the last one, 10 and 4.
Awesome. Good stuff. Yeah, very simple. Just knowing when to count for comparisons and exchanges. Very straightforward. I told you guys 95% of the code was going to be the exact same as the one prior. Which is why I told you kind of not to look at the old code to see if you can kind of remember the logic, recreate the situation. Because the point of this is to be able to familiarize yourself with these patterns and algorithms, so you can implement them yourself in your day-to-day life whenever you're doing coding challenges or anything that involves solving particular patterns, right? That's the goal here. Okay, we're gonna go ahead and move forward with the class. That was a nice little touch up from yesterday's discussion. The next thing that we have to talk about is gonna be recursion. Show of hands, who here is familiar with recursion or knows recursion?
I learned it. I don't know it, but I have learned it. Going through the courses with this school, so I have done it a few times. That's
Okay.
it. But it still confuses me sometimes when you have to, when you deal with the base case. But I do get it though.
Okay. The rest of you guys never heard of it? Never done it?
I'm in the same boat as Mike.
Okay. Well, if after today you still guys don't have an idea what the heck you're doing when it comes to recursion, once again, I can't recommend it enough. Grokkin's algorithm. That's a great way of explaining. Sure, buddy. So sorry, my kid was sitting on my lap. So we're gonna go ahead and talk about recursion. So recursion is we know that functions can't call other functions, right? But the concept of recursion is a function that's able to call itself, right? The act of a function calling itself, almost as if it's talking in third person, is what's known as recursion, right? It turns out that anything you can do with loops, you can also do with recursion. I personally hate recursion, and the reason I hate it is because it looks cool, right? It looks complex, it looks elegant. It's not that cool, right? If anything, it can increase your time complexity. So although it looks sexy, like it's overcomplicated for no like real reason. Like why would you do something so complex just because it looks elegant if it's not even going to be that efficient, right? That's my problem with recursion. But we're gonna learn about it because it is a concept, it is a thing. Some people do use it. But if I'm being completely honest with you, I have never used it in a work environment. Never has to. All right. But we're covering it so you're aware of the concept that is a thing. So yeah. So let's talk about it, right? All recursive functions are comprised of two elements, right? Two elements. This is pretty much the basics of recursion. The first element is your base case. This is where the recursive function stops, right? Sometimes you can have more than one base case, but essentially the base case, think of it almost as a condition, right? So whenever you do your while loops, you set a condition like while, like, the number is less than 10, continue running this while loop, right? And then after every time it runs through that while loop, you increase the number by 1, right? Therefore, allowing you to run this while loop for 10 iterations, and being able to stop at a certain point. That's kind of what a base case is in the concept of recursion. Like, it's essentially just a condition, right? It's a condition of when you want your recursive call to stop. right? And the second element of recursion is the recursive call, right? That is where the function is actually calling itself again, right? This is where we're actually gonna go ahead and dive deeper into the function itself. I am sharing my window, right? The slides, am I correct?
Yes.
Okay, awesome. All right. So a recursion example, right? So what two elements does a recursive function have again, right? So we just covered that. There's two of them. It is the base case and the recursive call, right? The base case and the recursive call. Good job, guys. Next, notice how the recursive call always contains a smaller version. So we're gonna look at this code, right, of the original problem. We have this function called factorial, and it takes an argument, which is num, right? It seems to be like a number, an integer. And here is the base case, essentially once again, the condition, right, of when we're gonna want to stop. If num is equal to 0, right? If num is equal to 0, then we're gonna return 1. If it doesn't equal to 0, what are we doing? We're going to return, notice, right, return num times factorial num minus 1. So this is the recursive call. So this is always the part that gets me. Essentially, the actual method within here is they're multiplying whatever num is initially, right? And then they multiply it by calling the function, right? They call the function. And we're gonna have to draw this to actually make some sense of it. Who does not feel confident at all with recursion? Okay, good.
Me.
I asked so I know if I'm wasting my time when drawing this or not. So we're gonna go ahead and do this. So the function was, sorry, my keyboard turns off when I don't type for a while. Factorial, right? And it takes in num. And then we say if num is equal to 0, return 1. Else, I believe it was num. What we're doing, return, yep. Else return num times factorial num minus 1. And this part right here, the num minus 1 is very important, right? Without this part, whenever we call the recursive call, if we do not adjust the arguments that are being passed within the recursive call, it will never equal the base case, right? How would num ever equal 0 if this never changes? So keep that in mind. This is how you get those infinite loops. This is how you get that message that says Stack Overflow. And yes, that is exactly where the website gets its name. So what happens when this runs the first time? All right, so this is a definition. At the very bottom, you're like, all right, I define my function. I'm going to go ahead and call this method. I'm going to say factorial. We're going to use 5. Factorial 5. You call this function for the very first time. And how we're going to describe it is by using the pancake method. I want you to imagine this is a pancake, guys, right? A layer, a pancake. We're looking at it from the side, kind of, right? The first time this call runs, right? This circle right here represents that first call. Factorial 5. The first time this function is called. This function is going to run. So 5 goes in here. It says if num is equal to 0, well, what is num right now? It's currently 5, right? So obviously it's not going to return 1. It doesn't exit out. What's going to happen with inside of this function as it's running, it's not going to meet the base case yet, obviously. So it's going to get to the else statement. And so they say else return num times factorial num1. So what this is doing, it's taking that 5 and it's going to multiply it. And then it stops there. It almost puts it on a halt, right? It pauses this function. Why? Why does it pause? Well, because this right here, this math equation never actually finished. It said num times factorial whatever. It got up to this point, but then once it reached the factorial part, opens up another function. Notice that we still have the first function. It's still open. Almost thinking of like the open ticket that never got closed out, right? Like a work ticket, right? It never got closed out because there was like something it depended on, like some second items or whatever, or something that, or someone else has to do something else for you, so you can't close out this work ticket because you depend on someone else's contribution, right? That's what that num is doing right now. That num can't finish because it needs whatever returns from this function it just called. Well, that function is ran. It's factorial num minus 5. So it's going to take the num within the initial call, which is 5. It's going to be passed in here, and it's subtracting 1 from it. So that second time this function is called, this time num is 4. Right? Because how it's passed in here, right? It's saying 5 minus 1. So the second time this function is called, this is 4. So this function never closed out. If anything, it opened up. It opened up a second one. Right? Baba, that is busy. Shh, that is busy. So what happens? So what happens is this factorial 4 runs. It goes in here. It's going to check, hey, stop, shh, go. If you guys hear him crying, let me know, please. Give me 2 minutes. Actually, less than that. He wants me to put Sonic on. All right. Hello? Can you hear me? All right, I'm back. I do apologize for that. All right, back from where I left off, guys. So essentially, once factorial 4 runs, it's gonna come in here. It's gonna check, hey, is num equal to 0, right? That 4. Obviously, it does not equal 0. It fails, that if statement, so it goes into the else, and it's gonna run this call again, guys. This else statement. It's gonna say return num, which is 4, times factorial num minus 1. Well, once again, it's gonna get to this part. It's gonna get to the factorial function, and this function is gonna stay on pause again, right? And that's how that's gonna go, guys. This is gonna go the exact same fashion until we reach that base case, right? Until we reach that base case, all these functions are gonna stay open because they never complete it. They never complete it, right? Because every time it gets to the very end, right, it just opens up another function and it dives deeper and deeper and deeper until finally, right? Let me go ahead and continue this drawing so we can kind of actually see what it looks like. All right, factorial 1. And then last but not least, we're gonna get the last function call. So factorial 1 goes in here. It's not equal 0 yet. It calls the function call one more time, and we get to this function call right here, factorial 0. So it's gonna get to factorial 0. This is after this function being ran Look, 6 different times. This is the 6th function. We dived in 6 functions deep, right? It kept calling itself. None of these have been completed yet. It gets to the final last one where finally it meets that base case. It's just say, hey, if num equals 0, return 1. So right, this is going to return 1. Right. So what happens? This closes out. This returns 1. Where is that 1 being returned to? Well, wherever this function was called. Where was this function called? Inside of here. Right? So 1 gets returned back. So right now we are currently inside of the factorial 1 function, right? So within this function, what is num? It's 1, right? Factorial 1, right? Inside of this function called right here, that 1 is num, right? So the factorial 0, would that return back into this function was 1, because that's the base case as well, right? We set up that base case to return 1. So essentially this is saying num times 1, right? Because factorial 0 return 1 once it reached that base case. We see that here, right? It returned 1 and it sent it back inside of this function, right? Because this is where the function was called. Well, num is also equal to 1, right? So this equation ends up being num times 1. So 1 times 1 ends up being 1. So this closes out. Well, we're returning whatever num times 1 was, which is 1, and that returns it to where? Wherever that function was called. It was called within factorial 2. Well, what's the num equal to inside of factorial 2? It's equal to 2, right? So it's num, which is 2, times 1, which is what factorial 1 returned to this function. It gives us 2 now, right? So factorial 2 returns 2. This closes up. Who does it return the 2 to? To factorial 3, right? What is num equal inside of factorial 3? It's equal to 3. So essentially, the else statement within factorial 3 says return 3 times 2, right? Because the 2 is what we got from the factorial 2 function call, which gives us 6. So this function finally returns something. Who does it return it to? This function call. So it returns 6 back in here. Well, what is the else statement within factorial 4? The else statement is saying 4 times 6. Right? What is 4 times 6? It's 24. Right? So this factorial returns 24. And then we get back to the very first factorial function we had called. Right? We finally get back up to the very top. And it's saying return num times whatever this factorial brought back to us, which is 24. So 5 times 24 gives us 96, I think. No, it's 100 and something. 120, I think. I don't know.
120.
Yeah, okay. All right, Owen. All right. Anyways. All right, so 120, right? So factorial 5 is 120. All right, cool. Nerd. Anyways, moving on, guys. Yeah, so 120. Does that make sense now, guys, of how that works? Of what's happening whenever that recursive call is calling itself? It's essentially placing itself on pause and diving deeper within itself. This is inception at its finest. Literally, inception at its finest. Right? And that's how that works.
I have a question.
I have an answer.
Because I can see the dangers in this. This is like making an infinite loop. I mean, that's something that can definitely happen. But outside of using it for simple math operations, where would something like this be used in the industry?
Like I said, I have never used it, so I can't give you an answer because I've never had a reason to use it. I wouldn't know myself. in the real world scenario. When you find one, Mike, when you get a job in software engineering and you run into a situation, I want you to call me and let me know what you use it on, because I've never used it. All right.
All right.
But yeah, so that's how that works. Yes, it does create, essentially it's a loop, right? It's a loop. It's doing something depending on whatever num is, right? It's depending on that. So what happens if you don't set a right base condition? Well, I said that earlier as well. You get an error. The error is called Stack Overflow, right? I'm sure you guys have heard of that website already. That is where the website gets named. But essentially, there is a limit to how many times a recursive call can call itself, right? And once it reaches that limit, because obviously there's probably some issue with the base call, it was never adjusted, so it just kept calling itself and never reached an end, then you will get an error saying Stack Overflow, right? All right, cool. So going back to this, so the function doesn't call itself indefinitely, leading to a Stack Overflow. Yes, that's okay. Whatever, stealing my thunder. But yeah, so that's how that works, guys. Right? Recursion example here is a better version of it. Remember, you can use an implicit return and omit the else condition. The only difference between this code, guys, and the last code is the fact that the return statement is inside of an else block, but here we don't have an else block. So obviously, if this if statement doesn't run, right, if it doesn't meet this condition, it's not gonna run line 3. Line 4 will run automatically. So if anything, it's a little redundant to add an else statement here. That's all that's saying. But pretty much it is the exact same code. All right, give it a try. All right, go into recursion intro.py. Recursion intro.py. There should be, I want to say there's like 4 or 5 problems within that assignment. So lesson 12, recursion intro.py. Oh, there's 3, my bad. There are gonna be three different assignments you have to do. They're fairly similar to each other. Time is 6:10. I'm gonna give you guys until 6:25. All right, so I'll give you guys 15 minutes. And then after the 15 minutes are over, I want you guys to go on a 10-minute break from 6:25 to 6:35. And then at 6:35, we will come back and talk about these 3 assignments. They're fairly the same. Might be a little confusing, but I'm sure you guys will get them. All right, so give that a try, guys. So let's go ahead, continue. We're gonna talk about the assignment. We'll do a walkthrough. These are fairly simple. Once you get the first 1 or 2 down, they kind of fall into place. So let me share my screen. You guys should be looking at my VS Code. So we're gonna create our countdown. All 3 of the assignments are using recursion. Countdown should be taking in a number. So it should be taking n. And within this method, we're gonna set our base call. And essentially what we want to do is take in a number and then count down from that number to 1, right? We saw the example here saying 5, 4, 3, 2, 1. So we want to return our last number, which will be 1. Once our recursion is complete, we're gonna say if n is equal to 1, I want to return 1. Notice that I put it in a string format. And my actual recursion call is going to look very similar to this, where it's going to be return. And I want to return what my n in a string format, right? Because I want to bring out 5, 4, 3, 2, 1. When the first time it calls, it should be taking in n. All right, so I'm gonna wrap n within a string. And then I'm going to add that n in a string format to an empty string to format it just like the demo is requesting of me. And then finally, the third thing I'm gonna add will be the actual countdown again itself, right? But here within this recursive call, I'm going to manipulate what my n is and subtract it by 1. So the first function call is going to set that 5 as a string at the very front of the string. It's adding an empty space. And after that, the next number that's going to be added to this string, which is 5, is going to be whatever countdown n minus 1 is going to return to me. So as this recursively calls itself, it's just adding all my strings together. Let's do print, we do countdown, and I'm at 5 in here. And if we run it, we see our example here, 5, 4, 3, 2, 1, printing out in the exact same manner that Dimble was asking from us. Right. And then for count up, it's gonna be fairly similar, guys. All right, we're gonna want to count up in a certain manner. We're still gonna format it the same way though. We're gonna say if n is equal to 1, I want to return my string 1. Right, because notice what it says here. It's gonna pass in if 5 is passed in as a function, right? It should return the string 1, 2, 3, 4, 5. So all I'm gonna do is switch how I'm formatting the string. I'm gonna say return count up, and here I'm gonna put n minus 1. This is where I'm gonna do the actual change of my argument. I'm gonna add an empty string, and then I'm gonna add the current n at the very end of my string, right? And then we can print that out, count up, add 5 in here. We run both these. We see the 5, 4, 3, 2, 1 from the first function, and the 1, 2, 3, 4, 5 from the second function. And then finally,
Roger.
yes.
I got a question.
Answer.
Why is it that putting the function first causes the reverse? Because when I'm looking at it, when it's going on that stack, it's going to be 4, 3, 2, 1.
Yeah, so the first time this runs, n is a 5, right? N is equal to 5. So that's why I put it at the end of my string, because technically at the very once it's all formatted, it's gonna look like I'm counting up, because the first time I make this string, I put 5 at the very back, right? Because this is the first time being called. Right, so right here, the first time it's called, 5 is being added to the back. To the left of it is an empty string right here. And then the second time it's being called, it's gonna be when it's being converted to a 4, right? So it forms that up. When the second time it's called, this is 4. That's gonna be formatted to the end, right? So technically, what's happening is this doesn't finish formatting until n is equal to 1, right? So once we call this for like the 6th time and it gets to 1, what's happened is that this is going to take the place of 1. It's going to come back, right? And it's going to go back to the function called the second to last function, which will be 2. So it will add the 1 plus an empty space and then the 2. So it's just being brought back backwards, right? Does that make sense, or do I need to draw it?
I hear you the way you say it makes sense, but I guess when I picture the call stack, what is taking place, like, so it's reading, it's doing a call to the function, but it's also adding the number to the string, which I see, but the strings go from left to right, not from right to left, and that's what's causing the confusion.
Right, so let's do this, right? I'm gonna draw it out. We're gonna say if n is equal to 1, I want to return 1 in a string format, right? Else return count up n minus 1 plus an empty string plus string n, right? We have this right now. So when this first runs, it's gonna run for the very first time. Count up gonna be 5, right? This won't form a string yet. Why? Well, because once it gets to the recursive call, it's gonna say count up. it won't even get to this part yet, right? It's gonna get to this part and it's gonna say, oh shoot, I'm calling it a function again. So it's gonna stop. It's not gonna stop, it's gonna pause, right? It's gonna pause. This doesn't format the string just yet, right? Because once we run this function, count up, n is equal to 5, we get to the else statement. I'm going to try to format it, but it won't finish formatting because we're calling it again. All right, but this time we're subtracting 1 from n, right? N is 5. So therefore, the second time we call it, this will end up being 4. Right? So now we have count up 4. Count up is going to run. It's going to check, hey, am I equal to 1? No, I am not. So I go to my else statement. It's going to say return. It's going to get a count up. It won't finish formatting. It's going to get to the function call, and it's going to pause again, right? And it's going to go even deeper. This time, it's going to subtract 1 from the 4. And it's going to call it again, right? So it goes deeper into its function call. Now we have count 3, right? Count up 3. So count up 3 runs. Is it equal to 1? No, it's not. It gets to the else statement. So it gets to the return statement. It won't finish formatting. It's going to get to this function and it's going to pause again. It's going to go even deeper. It's going to run the function again. But this time it's subtracting 1 from 3. So we have the next recursive call. This is equal to count up 2, right? 2 runs is not equal to 1. It gets to the else statement again. It does not finish formatting again, right? Because it has to run the function. It runs count up n minus 1. What is n? It's currently 2. So it subtracts 1 from 2. So we do our last recursive call. Count up 1, right? Because we subtracted 1 from 2. Now, once this function runs, it's going to check, hey, am I equal to 1? Yes, I am. So this right here is going to return 1. Right? It returns 1 into count 2. Right? So now, technically, count up closes, right? Because it runs this part. It does not go into the else statement. Count up closes, and it goes back to count up 2. So this is what count up 1 looks like, right? This ends up returning 1 back into count 2, right? Once this closes out, it takes the spot of whatever was in here, right? Because when count up 2 called it, this is 2 minus 1, right? Count up 2 called the count up function where n is equal to 2. It subtracts 1, therefore being 1. That means once this runs, it checks that it's equal to 1. So this returns to us 1. It's going to add that 1 to the string. 1 to string n, right? We are currently inside of this recursive call. What is n? If we're in this recursive call, what is n?
If we're in that recursive call, then n would be
n is equal to, correct. So this essentially is doing 1 plus empty space plus 2, right? That just formatted the first part of my string. So it formats it and then it returns it, right? It returns 1 plus empty string plus 2. So now we close this off. This function, count up 2, is going to return this to us. That's being returned into here. Correct? You're still with me?
Yes, I am. As you're doing this, it reminds me of the is it LIFO, last in, first out?
Yes, kind of like
That's
that.
what, yeah.
Right? Give me a second, Mike. Just ask me real quick. So, all right, no problem, buddy. So this function count up to is going to return to us this formatted string where 1 plus empty space plus 2. That returns back into count up 3 function. So count up 3 is running, right? We are currently inside the count up 3 function. And within the count up 3 function, right, we still have this count up n minus 1, right? This is being returned into here. So this string that was brought back to us from the count up to recursive call takes the place of this. So this ends up becoming this, right? We are still within the count up 3 function. So what is n?
3.
3, right? So this function right here is going to return to us 1 plus an empty space plus 2 plus an empty space plus 3. And it's slowly formatting it as it's coming back to us, right? Now count up is complete. And we go into count 4. And then count 4 is going to do the exact same thing. It's going to format the string, right? This ends up becoming 3 plus empty string. We are in the count 4 function call, so n is equal to 4. So this function call returns to us this string, 1 plus empty space plus 2 plus empty space plus 3 plus empty space plus 4. That closes off this function call, returns it to the very first function call we had ever called. And that adds the 5 to it. Does that make sense now, guys? Is that a little bit better?
Yes.
Right. So it's not formatted until it gets to the very last recursive call, and then it starts formatting it backwards to us. Right. That's how that works. That's why whenever we did it backwards, that's why it works the way that it does. Okay.
Thank you.
No problem. All right. So that was the count up. Next was the sum count up. So we're going to find sum count up. And we're saying if we have to get a call, takes in an integer parameter and returns the sum of all the integers from 1 to that number, right? So essentially, we're going to do this until n is equal to 1, right? And then we're going to return 1. Notice it's a string. We're not formatting no string. We're getting a sum. We're going to be adding these numbers up. So we want to return the actual value itself. If it's not 1, then what it needs to do is return n plus sum count up n minus 1. Right? Once it gets to the last recursive call, n is going to equal to 1. So it'll return 1. This will take in the place of 1. 1 minus 1 is 0, plus 2, so on and so forth until it gets back up to the highest number, adding it up. Right, just like we saw before, sum count up. All right, and we can do if we do 5, like we did before. All right, it should be 15. 15. We're adding all the numbers from the 1 back up until it gets bigger, back up to the point it's 5 again. Right? And that's how these 3 were supposed to run. Any questions? All right, guys, moving on. So that took care of the recursion intro. The call stack. When running a recursive function, multiple copies of the function will be active at once, but only the most recent one will be executing. The others are paused while waiting for a result, right? That goes back to the drawing I showed you guys. all these are paused. The moment it gets to that recursive call, it pauses it and it opens up a new function. So on and so forth until we finally get a result that's going to equal to our base call. And then once the result is being made, every single one of these starts closing back in the order that they were last open. Python tutor walkthrough. So there is a link in the README if you guys want to try this out. It's a tutor for Python. So if you feel like you're still struggling with Python, you can try it out. I have yet to try it out myself, even though I've been teaching this. But you guys are more than welcome to use this. Next gonna be recursive mult.py. We have 2 more assignments. Let's check out recursive call.py. Recursive mult.py. All right. Oh, is there no assignment in here? I'm sorry. Can you guys hear me?
Yes.
Okay, for some reason my VS Code disconnected. What's going on? Give me
Are
a
you
second,
on?
guys. Can you guys hear me?
Yes.
I
Are
don't know
you
what's
on
going
something?
on. What? I'm sorry.
Are you on a virtual machine?
I am.
Okay.
I do not know what is going on with my VS Code, guys. I'll try to figure it out. But in the meantime, do you guys have recursive mult.py in your folder?
Yeah, we do.
Is there an actual content in the README?
Yeah.
Okay. How many assignments is there? Is it just one or is there multiple of them?
It's just one.
Okay. Give that a try, guys. I don't know what it looks like. My VS Code is closed. Let me know when one of you guys finishes it so I can kind of guess how much time to give the rest of you guys. I don't know what is going on with my VS Code. It just stopped working. You guys can see this, right? I gave me an error. Okay. Yeah, go ahead, try the recursive mult while I fix my VS Code. Oh my God, I was not recording. No. I'm so sorry. I was not recording, but we are currently going over lesson 13, Python, Regex, and ASCII values. So back to where I left off at. It's too much to recap. It takes in the regex program mean. So it will capture program and mean, but what are we going to replace it with? Well, when it runs line 9, it's going to get to the regex. It's going to grab the program, and then when it gets the mean, it's going to save it into this group. Right? It automatically creates it. But right now we're not accessing it yet. When do we access it? We access it here with what we are going to replace it with. Right? And that is the function that we talked about, right? We create that function up here earlier. We pass in the function as a variable, or not as a variable, as an argument. So this function runs, and when it runs, it takes in the match and grabs index 0, and it runs this, right? It will replace, it returns dancing if it has dancing. It returns dance if it's dance. And then we see here, yes.
Is the match object then at that point, since it's using dot group? I mean,
I guess, yeah, I would say it's an object. We can see it.
It's an
here.
object of the regex.
Yeah.
Almost similar to the JavaScript. That's what it seems like it's doing.
Let me do an example here, and I can print out what it does for you. Regex.py. We have define, replace. Actually, let's not even do the function yet. Let's go ahead and create that sum string. is equal to learn to program because programming is cool. That string is equal to re.sub. I haven't imported re yet, so I'm making error. Program mean question mark comma. I'm gonna say dance for now. We'll use the first example. I want to print out that match right now so you can see. All right, let's go ahead and import re so we can use it. Right, and then let's print out that string. Right, learn to dance because dance is cool. Well, let's also print out match. Blah, 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 match dot, is it re dot match? Okay, there we go. Re dot match. What did we do dot group? What was it? There's a specific way to get that match. Where's that? I forgot the way of doing it. Where is match? Is it, sorry, it's been a while since I've done this. It might be dance string dot match. Match pattern and string.
On the slide,
How did it
did
go?
it have match by itself though?
Does
Or
it?
was match a
Been a while since I've done this. Give me a second for match and matches. I'm gonna show you what match does. Match start. Why is it? I don't think it's gonna work this way. Pretty sure it's supposed to be re.match. What? Hmm. I'm trying to find an answer for you. Go to where the heck is it? Let's wait a bit. Once we get to the other ones, we should be able to answer that question. I'm having some difficulty finding you the answer,
okay. Thank you.
but I will answer that question for you. I promise you.
Okay.
That's cool. I wonder if we actually do the function, it'll show it for us. Let's do define, replace, match, if match, or let's actually print match. If match dot group 0 is equal to programming return dancing, return dancing. We should be able to do this, and we might be able to actually see the match from there. Okay, there we go. So I don't know why I was having so much difficulty finding a match. Okay, so watch. So it runs the match, right? It figures out it is a match, and it's gonna save it to something. Notice here, it's a match object, and what does this object have? It has spans, and then the matches is caught. It caught program and programming. Right, program and programming. So it did create groups. What's the first one in here? It is program and then programming. Let's say print dot group. It prints out both programming and programming. There is a method to grab certain ones. What's it called? For match. No, where's that? Where's that? Where's that? We have match dot span, match dot start and end. I guess I was doing correct because I was having issues. Well, it puts them in a group. All right, it is an object. All right, puts them in a group and it saves them, everything that it caught. But notice that there's group 1 and group 0 and 1. When I put 1, it says learn to dance because dance is cool. But when I use a 0, it learn to dance because dancing is cool. So programming is actually saved into index 0, while program is saved into index 1. I don't know why it's such a weird order, but when I print them out together, program gets printed out first. That's weird. But both of them are saved, right, into this match group. It creates an object and it saves what it found within a group.
Is the group an array, a dictionary?
It is for sure it's an object. Let's look at it. RE object. I want to say it's an object with different data members, one being span and one being match.
Okay.
Right. It's an object. Recall our objects in class listing is not necessarily a dictionary or a list. It creates an object of that item. One of the objects is program and the other object is programming. Those objects are saved within the group. What did we print out? Type. Class string. Those are all strings. What do we print out max itself? Rice cake? Give me a second, buddy. Take a 1 minute break. I gotta give my son a rice cake. And then we'll be it creates objects of those matches. And it saves them, and then we're able to access them by index. I'm going to assume that group, I believe I think it's going to be a list, if I'm being honest with you. I'm having trouble trying to get exactly what type it is. When I put the type around the entire group itself, it's returned to me a string, which is weird. It's hard to visualize that. Just know that it's capturing whatever it's encountering, and it's saving it as an object, and you're able to access all those groups. Like that's honestly the only thing that we really have to worry about, knowing that we're able to grab stuff and save it into something. All right,
Thank you.
no problem. Hopefully that helps. I'm sorry if I just confused you further.
No, that helped. I was just wondering what that match was because I was like, okay, how in the world are they using that?
Yeah. So we saw that. Now, an example of the flags parameter. This one I'm not familiar with. So we have hey you, yeah you, I love to code in a string. They use once again the substitute method, and then the regex is a bunch of ors, right? So I want to grab I or love or to or code, and I want to replace it with ski within string, right? When printed out, it says hey you, yeah you, I love to code. Notice that it didn't capture any of them, right? Why is that? Well, because they're in capital letter, but we are looking for a lowercase I love to code, right? But you're able to add a flag, right? And I believe there's multiple flags. This is just one of them. Is being able to add like a condition where we can ignore cases. So many flag parameters, just giving one example here. So yeah, so this one specifically is able to ignore whether it's a lowercase or uppercase string that we encounter. I'm not familiar with all these flags. I don't use these often. Just know that they are available to you if you ever need to set conditions. You can check those out.
I have a question for the flag part. Does it have to use the module itself, or are we able to pass in like the G or the I, those, or it has to be that?
The G or the I? What do you mean the G or the I?
So you know how when you do regex, when you write it, there's certain things that are flags for it, and you can just pass in the flag for it. But what I'm asking is for here, it's using the module itself.
I do not use flags often, so I don't know if there's alternatives, but I know there's a list of them.
Mm-hmm.
Are you asking about why it's doing RE dot ignore case? If you could use something else except RE?
Yes, that's so. What I'm asking is in the Python
Oh, like
when
this?
when you're yes. So up in other words, up in Python, do we have to use the module to set the flag, or are we able to use the character to just do it? That was my question.
Oh, okay. I mean, I would assume it would be one or the other. Um, I don't think if the G works for you, then what's the point of flag, if that makes sense? But I think just different ways of doing the same thing.
Okay,
You know,
thank you.
I see the G flag. I've never really used the G flag myself, but because I usually just do if the G stands for uppercase, and I typically just do A through Z and then all caps A through Z. I'm looking for both, one or the other. Those are what I typically use when I'm trying to ignore cases, case sensitivity. So I've never had to use a G. I guess there's 3 different ways of doing it. So whatever works for you and what you enjoy doing.
Okay.
The dot replace and the dot sub module, right, versus each other, right? So the sub module is more versatile than the built-in replace method. Forget about replace, master the sub module, right? The dot replace is another built-in method that we use. It's kind of like the is to lowercase, uppercase type of method that we've used before. Notice here that this is like not part of the RE module. It's just a Python thing that comes with the default version of Python. We're able to replace the word with something else, right? So hey you, yeah you, I love to code. It replaces love and hate, but it's not as powerful as being able to use the dot sub module. The RE dot find all. All right, the RE dot find all method scans a string from left to right, searching for all non-overlapping matches of the pattern or string that is passed in. It returns a list of matches, right? So we see here we have, hey you, yeah you, do you love the code? It takes in you and the string that we're trying to search through, and it returns to you a list of all the matches that it has found, right? So it found 3 U's within this string. All right, so we're trying to find all the.
We can't hear you when you
I think
moved
your
your
mic's cutting
earpiece.
out.
Yeah, we lost you when you moved your earpiece.
Oh, I'm sorry. Man, I paid like almost $200 for this stupid headset, but I get more issues with it than anything. Finding all the characters, right? So we saw here we were able to grab all the occurrences of you. So these are all situation based, guys. So what you're trying to do is what what it's gonna depend on what method you would use. Not all these will ever really be helpful for you. Um, but it's all gonna be about what you are essentially looking for. Uh, with the way you guys are going to use regex will be just creating the pattern. If I'm being honest, you're going to use the RE to create a pattern, and then you pass that into your endpoints to limit what can be added. You're not going to have to use the find all or substitute method really. You're just going to take advantage of the actual pattern of regex. But you won't have to use these methods. But this is just to familiarize you with them. Finding characters in a set. So if you want to find all characters alphabetically between A and E, notice here that we do find all, and then they put the A through E within these brackets. And then it returns it once again in the list, right? Because it's still the find all method. And it finds E, A, D, E, C, D, E, because it's telling it a range from A through E. Nicolas, stop doing that. Finding integers and strings, right? So you want to find all the digits. The best method of doing that is using the D pattern with your regex. This will grab all the digits within your string. So they're still using the find all method, but the actual pattern itself, they use the meta character lowercase d, and this will find all integers. I believe the capital D will find all non-integers, if I remember that correctly. So you can use the lowercase d and uppercase d depending on what you're looking for, whether you want to get all integers or no integers. And they're replacing it for the sum string. Notice that it returns the list of all the integers that it found because it's still the find all method. Here is the example of those special characters. We just saw the lowercase d, which matches digits from 0 through 9. And then here, as I mentioned before, the capital D, it grabs all non-digits, right? Anything that isn't 0 through 9. Right? S is another powerful one. This is for white space. So this will capture anything that is a white space character or non a white space character. The T is a tab, N is for new lines. I don't know what R and F is. I have yet to use those. But you already captured the N whenever we were working with our CSV files, reading and writing. We were using the /N to create a new line. So those all create white space, which is why we would use the dot strip method to remove any white space, if you guys recall. So lowercase s and capital case S will work with the white spaces. The W's is for single word characters, right? Or match a non-word character. My other favorite one here is honestly the dot, which will match any character except new line, right? Any character except new line. You probably use this a lot too. Finding a particular sequence, right? So finding all sequences start with HE followed by any 2 characters and an O. All right, so we have our string here, hello, heyo, hebo, and hekyo. All right, so we want to find everything that has an HE and ends with an O, but we do not care what 2 characters are here, right? The dot is placed twice. So that means we're going to get 2 characters, right? What those characters are could be absolutely anything, right? Per the special character, the dots, right? We're gonna grab any character except new lines. And because it's added twice, we're gonna grab two of them. So it could grab hello, it could grab heyo, even hebo, but it's not gonna grab hekyo. Well, why? Sure, this starts with an HE and ends with an O, but there's three characters between the start and the end of these, right? We're looking specifically for a character that starts with HE and ends with O and only has two characters in between. So hekyo will not be captured, right? Because it does not meet these conditions. It has three characters between the E and the O. Right, so and we see that here on the list for find all, we have hello, heyo, and hebo, but hekyo is not present. Many more find all examples, so we covered a few just to show what's possible. The find iterable, so returns an iterable with every match object. We have hello here, and then it saves it to a match group like earlier. So we say for match, it matches, right? Because the find iterable is going to return the match groups, and we see that it captured hello twice, and it'll tell you the span. The span is where it found it, right? From where that word is spanning from. We have the first hello, which spans from index 0 up to index 5. And the second one is at index 19 to index 24. Right? They print out those matches. All right, so it creates a match object, right? Returns an iterable with every match object. The dot match returns the match object only if it's first in the string. So they finally use the match here. We have re dot match. We are trying to match hello. It finds it once. But if it's in the first in the string, right? Notice that it's not first in the string. Right? Here, hello appears twice. It's only in the string in the start once, obviously. So it only returns one hello object, not the second one. The dot search. It returns the first match object in the string. Right? We are going for hello. And this will actually search the entire string until it finds the first one. Whereas the match one, it has to start in the beginning of the string, correct? Here is not the beginning, it's the third word within the sum string variable, but it's still able to find it because it's searching for it, right? And it's able to return it for us. Same thing here, it does the same thing, but it only captures it once. The first match object in the string. The dot split. We have hello with some random characters and iterables. We are trying to split this string at the @ symbol, right? The @ symbol appears twice between hello and the integers, and then again between the integers and the pound signs or the hashtags. And it's going to split that string and it saves it to the variable called matches, which returns a list, right? So matches ends up being the list of the words that we were able to split at this pattern, which is the @ symbol. So hello, 1, 2, 3, 4, 5, and then 4 hashtags. Match object utility, right? So it gets the indices of the string matches. So we have yellow, fellow, hello, mellow, hello. We use the find iterable one, right? It finds the hellos. And then we are looping through all the matches. It seems to be like, it might be a set, actually. I think it might be set. But we're looping through all the matches that I found of hello, but we are using the dot span method, right? It almost seems like it's like a data member almost, right? Because they are objects. So they use a dot span. And notice that if for every single match that it encountered, it will print out the span for it. It won't print out the entire object like we saw earlier, which was here, right? It doesn't print out the object name in its contents. It'll just print out the span. Where do you go? 14, 19, 26, 31, that's where the hellos are found. Again, the start and end indices. So instead of grabbing here where we got the set, we're able to grab start and end of it specifically. So if you don't want to grab just the entire set of the span, you can get the dot start and the end, one or the other, and it'll give you those as well. I've yet to have to use any of these. Just a quick disclaimer. Match object utility. We have groups or individual matches. It becomes important later. So we have yellow, fellow, hello, yada yada. Find iterable, same thing. We're looping to the matches, but we use the dot group method, and it prints out the hello twice. It prints out every group, and we saw that earlier when we saw the programming. We already used this method. Next is exact numbers and ranges. So we can get specific numbers of characters in a row. We talked about the curly brackets grabbing you how many we want of them. We want to grab 4 digits, right? 4 digits. It has to grab 4 digits consecutively. Notice that it'll match it because we're using the find iterable one. We print out the match. It only grabs this set of characters 1, 2, 4, 5 because there's 4 digits back to back. It does not grab 14, right? Because there's only 2 digits back to back. Right. On the second one, we get a range though, right? This is from 3 to 5, right? So we're willing to grab from 3 to 5. It still grabs this one. Notice that it does not grab this because it's only 2. So you're able to get specific numbers of characters in a row. Finally, we have the assignment for vowels and domains. And I'm going to stop it here, guys. Let me pause the recording.